So what I'm going to talk about today is basically continuation of the same concept, frames, but the different types of frames, which we call them machines. So this is lecture 19. Oops, let me switch back. I put it on the. So this is lecture 19. We are going to discuss machines, which are in a way a special types of frames. The difference between frames and machines are that, this is better, that frames are structures that are externally supported, but machines are not necessarily externally supported. They can move around. A pair of pliers, a stapler. These are frames made of different components, right? But they're not supported permanently in one location. You can move them around. There are, of course, machines that may be fixed someplace, but in general, they're not. Okay. So, so I would say not necessarily, because that's not a general rule, not necessarily fixed to a location. And number two, in machine problems, or at least in most of the machine problems, okay, you're typically asked to find not all the unknown forces. You may, but not necessarily. So I'm going to do two problems, one of each type. That is, one that the machine is not fixed to a location, and you're asked to find all the unknowns. The other problem, I will do a machine that is fixed to a location, but you're not asked to find all the unknowns. So let me start with this. So I actually had started that. This is the prune sort of a device that I was going to draw. So as you see that in, doing the machines, there's a little bit of artworks also involved. So I'm just drawing this. That's what I was trying to do. But this problem in that book is only asking you to find one unknown. I'm going to make it more general. So you have a machine that is basically is a prune. Okay, it is designed to cut piece of a branch. Okay, that's at point A. When you exert a force by your hands. Okay, so this machine is subjected to these two forces of 2 Newton. That is by you're holding it like this, pushing it. And it has all these components. So let me label these point C, point D, point E. Okay. Also, let me give you all these dimensions. These two are at the distance of 60 millimeters. Distance here is, okay, you need these also. This is 25, this is 30 millimeters, okay? And the distance from here to here is 150 millimeters. And this distance is given as 10 millimeters. And this angle is 45 degrees. So In this problem, we are asked to find all the unknowns at all the joints, all the components, including the force that is exerted due to the pushing by your hand on this branch that is required to cut that branch, okay? So, procedure is the same. Start with X, Y coordinates. So I would set that up. Step number 2, free body diagram of the structure. As you can see, since this is not fixed to any location, you don't have the free body diagram of the structure. Free body diagram of the structure is what you've been given. So this is actually the free body diagram of the structure. You've been given that. So this is of no use. Then you try to free body diagram of all pieces, and you watch out for two force members. Okay, so let's do that. First of all, do I see a two force member here? Of course I do. Look at member DE, connected only at the two ends, right? The two ends are pins and no load acts along that member. Okay, so if I start with that, this is member DE, and let's say forces that act along a line connecting these two is F equal and opposite in direction. So that's the first free body diagram. How about this guy? Let me draw this guy. Okay, you have this free body diagram. So this is C, okay? And what else? You have point D here, okay? These are along the same line. So maybe I should have drawn this better. A little bit of artistic talent is required, right? So this point D, and this is point, let's call that G, and this point I call that F, okay? So at point G, you have an external load of 20 Newton. Point D is from here, so this is that force FDE acting at 45 degrees. Let me resolve that into its components. So this is FDE square root 2 over 2. This is FDE square root 2 over 2, cosine of 45 degrees. And at C, you have these two unknowns, Cx, Cy. So this is free body diagram 2. So what else you have? This guy, free body diagram of the blade and this piece. Okay, so let me do the blade first. So you have this blade here. This is point E. This is point B, which is 10 millimeter, the vertical distance between them. So this is point B. This is point E. Here, there's a force. This branch, let's assume, is frictionless and is acts like a roller. So there is a vertical force that is generated here. And at point B, let's say the two unknown forces are going to be like this. So By, Bx, and obviously at E, point E, you have the force coming from here. So that would be the force of dE. You have resolved that, of course, into its components. So square root 2 over 2f dE square root 2 over 2f dE. So that's the free body diagram of the blade. So I have one more piece, which is this handle. So that's this guy. Okay. So you have this piece, which goes like this. So you have this force at point F, 20 Newton. This is point B, and this is point C along the same line. Okay, B and C. Okay. And that distance uh, is not given, but you can find it. So this is point B, this is point C, and then you have this A, F at A. Okay. All right. So again, at B, these were the directions, should be opposite to those here. So BY, BX, and at point C, opposite to what you had assumed here. So you have CX and CY. Okay. So let me put these distances so that they will be readily available. 150 millimeter. This distance is 60 millimeters. And here I should have put it also. These distances were given. This was that 60 millimeter. This is 55 millimeters. Okay. And that's it. Any questions as far as the problem goes? Um, any ambiguities, anything that you want me to clarify? If not, let's proceed.
You said at the beginning that the like free body diagram of the overall machine, like the
Mhm.
little clippers, that it wasn't useful. Why was that?
Because you see the machine is not fixed to any wall or anything. You're holding it. And the way you're holding it, the forces that are holding it are given. So if you separate the machine from the environment, is already separated. And the forces that are acting on the two handles are given. That's the difference between this type of machines and frames. That is not fixed to anything. These two forces are holding it. So what is a free body diagram of the machine? Meaning that the whole structure not cut into pieces, but just showing the external loads coming from the supports, holding it, that's it. So there's no unknown in that free body diagram that you're trying to find, in contrast to frames, because those external unknowns comes from the support that is holding the structure in place, and the support, in a way, which are your hands, the forces coming from your hand are given. Does it
Okay,
clarify?
thank you.
Sure.
That helps.
So it comes out to this. So you drew the free body diagram, you watched out for two force members. So the last phase is start with a free body diagram with minimum number of unknowns and move on. So I have one, two, three, four free body diagrams, right? So this one is already out of the picture, right? I cannot use that. So I have three of them. So let's look at it, see how many unknowns I have in each. Here, one, two, three, one, two, three, four, one, two, three, four, five. So obviously, I'm going to start with this one, right? So let's start with free body diagram number two. I start with that by taking summation of moments about C is equal to 0. Okay. And I have these distances, by the way. This is 25 millimeters. Okay. So, and this one was 125. So taking summation of moments about this, I have moment of this force, which is negative, right? So I have negative square root 2 over 2 of F dE. Okay, this one doesn't generate any force. And then this one would generate a positive force of 20 times 150 is equal to 0. That will give me F dE. That comes out to be 169.7, comes out to be positive. So the assumed direction is right. Okay. So if I write summation of forces along y equal to 0 for the same, I have cy minus square root 2 over 2 of FDE, 169.7. I have plus 20 is equal to 0. That gives me cy of 100.5 Newton. Okay, so this equation, I have one more summation of forces along x equal to 0. I have cx minus a square root 2 over 2 times 169.7 equal to 0. That gives me cx, which will be 120.5 Newton. All came out to be positive, so the assumed directions are right, and I found all the unknowns on this one, so this free body diagram is out, okay? And obviously, you need to put check mark on all those unknowns you've already found, Cx, Cy, and F. So here I have 1, 2, 3 unknowns, 1, 2, 3 unknowns. So I can use either of these two, okay? So I will use free body diagram number 3, okay? So if I use free body diagram number 3, okay, this is what I get, okay? Okay, so I use free body diagram number 3. I had done this problem, okay? So I will take summation of moments about point B is equal to 0, okay? So the only unknown is FA. If I do that, I have 169.7, okay, times square root 2 over 2, okay, this one times the distance of 55. Then I have this one also positive, so 169.7 square root 2 over 2 times the distance 10. And then I have this force, distance 60, generating a negative moment, minus F times 60 equal to 0. That will give me the F force that comes out to be 130 Newton, positive. So I solve for this and this. Now I can simply write summation of forces along x is equal to 0. So I have negative bx, okay, plus square root 2 over 2 of 169.7 equal to 0. That will give me bx, which comes out to be, okay, I had solved this one. I can find it. I think it's comes out to be 120.5. Let me double check though. Let me double check here to make sure that is correct. Okay, so we have, okay, 169.7 times 1, 2. It's 120.5, yes, correct. Okay, that is positive. So this is correct, and this is correct. I found them. Summation of forces along y is equal to 0. I have negative by plus square root 2 over 2, 169.7. Okay, plus 130 is equal to 0. That gives me by, that comes out to be 250.5 Newton. So I found this one and this one. So what happened now? As we know, we have ended up with one free body diagram that we have not used, which is free body diagram number 4. Use that to verify your answers. I'm not going to do for all of them. Let's just use number 4 to see if summation of forces along y is 0 or not. Okay, so at by upward 250.5, cy downward negative 100.5, f downward 130, and then 20 downward, right? These add up to be 0. So that means the answers that I found were correct. And this confirms that. Any questions? Let me tell you this. This was actually given as a final exam problem, and you were only asked to find this force that this pruner exerts on the branch. So if you look at it, if that was the only force you were going to find, you did not even have to find Cx or Cy. Why? Because once you found f of dE, which is what we did from here, right? You went to this free body diagram, you had taken the moment about point B, right? That gave you directly this force. And then you didn't have to, solve for all the other remaining unknowns, which is many times that's the way the problem is stated. You're asked to find only certain unknown forces, not all of them. But I did this problem completely, although the problem statement is not asking for that, because I wanted to show you the difference between the frame and the machine problems, which the only difference is that you don't have the free, if the frame is not supported externally, fixed to somewhere, is you don't need to use the free body diagram of the whole structure, but yet you still take that apart, watch out for two force members, go follow the same procedure. And I emphasize and re-emphasize and re-emphasize, and I may sound like a broken record, but frankly, in my experience of having taught this course for decades, I have always seen many students that they don't realize that the whole objective of statics is to teach you the process, meaning that 80% of the problem is being able to set up those free body diagrams. Applying those algebraic equations of equilibrium is a piece of cake. That's not what you are supposed to get out of statics, but being able to draw the free body diagram. So I really want you to remember this methodical approach. 20 years down the road, you may not remember anything about, how you did, apply equations of equilibrium. But it is important that you remember and know how you solve these problems. Free body diagram. Okay, any question? If not, I'm going to do another problem. Okay. This time I'm going to do a frame problem that the frame is actually attached. It's to a fixed, permanently fixed to somewhere. However, you are not expected to find all the unknowns. And this is the problem that I've chosen from this book. In fact, this problem, if I'm not mistaken, was also given as a final exam problem. So this is the problem. You have a pressing machine. So this guy is exerting a force. The goal is that you want a 300 Newton force to act on this piece of lumber to hold this in place. Maybe this is a clamping device or whatever. So you want to know how much force is required to create a vertical force of 300 Newton here. That's what the problem is. So this machine is composed of this piece where you put the handle that you push that, this element pinned here, and then this piece, which is like a dog bone, right? And this fixture, okay? So let me say this, repeat that again. If you're not asked to find all the unknowns, you draw the free body diagram the same way you did. But you don't, first of all, you don't have to draw all the free body diagram. You draw as many free body diagram as you need to solve for those unknowns. So let's just start with knowing that, okay, you don't know where to start. So let's begin the same way, okay? That is step number one, setting up X and Y coordinate, okay? And you try to set up the free body diagram, okay? So this is the free body diagram. I will, okay? Maybe I'll bring it down a little bit, okay? So I will draw the free body diagram of these two pieces first. So let's do that. The dog bone part, which is a piece like this, okay? Which has all these fancy stuff, the screw attached to it, whatever this is, okay? But the bottom line is, this is designed to apply a force of 300 Newton, 300 Newton on this. So that force of 300 Newton is acting obviously upward on this piece, okay? And this is the piece CD, as you can see, is bolted or riveted here, riveted here. So you have what? You have two unknowns here, CX, CY, DX, DY. This distance is given 60 millimeter. So this is the first free body diagram. So I drew the free body diagram of this piece. Okay. Now, how about this handle? The handle looks like something like this. This is that handle. Okay. This is that handle. So it goes like this. So you have a force perpendicular to this, which you're trying to find. This is that point C, okay? And this is this point B here. See this point where you have this piece attached to it. What is this piece? Pinned at the two end, no load acts along that, and these two ends are the only two places this is connected to the rest. So this is a two-force member. These angles are given, by the way. The orientation here is 30 degrees. You've been given that. And this force that is coming from member BE, that two-force member, also this angle is given, 30 degrees. So at point C, and the distance between point B and C are also given, is 30 millimeter. Point C, this is the assumption for the directions of forces acting on that member. So you have to have CX and CY acting this direction, okay? And all these distances are given. In other words, this distance from here to here is given as 275 millimeters, okay? Distance from here to here is given as 70 millimeter, okay? All right, so needless to say, you need to resolve these forces into their components, okay? This is 30 degrees given. So you resolve that into its components, okay? You have F cosine of 30. This is F sine of 30, which is 1/2. This is square root 3/2, okay? This one, resolve that, okay? So I resolve that one, I resolve this one. This is FDE cosine 30. This is FDE sine 30. So these are the two free body diagrams. Problem is asking you to find this force. You look at these two free body diagrams, 1, 2, 3, 4 unknowns, 1, 2, 3, 4 unknowns. So you wonder, can I solve this problem, actually solve this problem or not? Let's try, see where we go, okay? So let's see what we are gonna do here, okay? So I would just, because I don't want to go and draw the free body diagram of all these other pieces, especially that I notice if I want to draw the free body diagram of this structure as a whole, there's one pin here, so I have 4 unknowns. So that's not going to give me any options either. In fact, I'm adding 4 more unknowns here, okay? Since I've been asked to find only one unknown, always watch out. That means you should be able to, if you're asked only to find certain number of unknowns, you should be able to solve the problem with those limited number of free body diagrams, okay? So I followed, of course, a procedure by setting X and Y. I did find the two force members, okay? Now I'm drawing the free body diagrams, but I only did for 2 of them. Let's see what I can do. I will start with this guy first, okay? Let's use a free body diagram of this guy, okay? And see what, we can accomplish here, all right? So let's see, I had solved this problem somewhere, okay? All right. So I'm going to take free body diagram number 1 and write summation of moments about D is equal to 0. Start with that. So that will give me Cx, which is positive, times this distance of 60. Okay. This would be negative 300 times this distance, and that is given. This distance was given is 255 millimeters. So times 255 is equal to 0. That will give me Cx of 1,175 Newton. Okay? Do I need to try to solve for the other unknowns? Let's see first. Do I need that or not? If I go here, okay, and now write summation of forces along C. So I'm going to go to this free body diagram, write summation of moments about point C. Okay, I have this one, and this one, and this one. So let's start with this guy. You have FBE square root 2 over 2. I'm sorry, square root 3 over 2. That's cosine of 30, and this is 1/2, times 70 positive. This one generate a negative one, FBC, BE times 1/2 this distance 30. So that's the moment that these two generate about point C. Okay. How about this one? This distance I need. This distance is 275 sine of 30. So this is 275 times 1/2. And I also need this distance. Well, this one part I have, I need this one. This would be 275 cosine of 30. So 275 square root 3 over 2. Okay? So moment of this force about this point would be negative. I have F, okay, times 1/2 times this distance, 275 divided by 1/2. And then this one, this is the vertical distance. So minus F square root 3 over 2, okay, times 275 times square root 3 over 2 plus 70 is equal to 0. If you simplify that, you will see that you get an equation like this, 45.6 F of BE minus 335.6 F is equal to 0. Okay? Since I had found C of X here, as the next equation, I use summation of forces along X equal to 0. So I get Cx minus F dE sine of 30, which is 1/2, plus F sine 30, which is 1/2, okay, is equal to 0. And that will give me 0.5 F BE minus 0.5 F is equal to 1,175. So I ended up with two equations, two unknowns that I can solve for both of them. Okay? To get F, that comes out to be 370 Newton, and FBE, that comes out to be 2,719 Newton, although I did not need this because the problem is only asking you to find this unknown, which I could find. Okay? So True that you have 4 unknowns on each free body diagram, but 2 of them are common between the 2. So as far as the total goes, you have 1, 2, 3, 4, right? 5, 6 unknowns, and you have 6 equations of equilibrium, 3 for each. So you could see that you could solve for the unknown that you were asked for to find. Any question? No question? All right, so with this said, we are done with the coverage of frame and machines. And next time, we will go ahead and introduce the new structure, which is the frame structures, okay? And let me say that I had recommended an online course that I have on Udemy. I strongly recommend, I suggest that you take that course. I am really proud of that course. I still believe I have never seen a course like this, so comprehensive on coverage of trusses. I have broken down clearly into 7 steps, 7 easy steps that methodically shows you how to solve, truss problems. You have the link in your syllabus, so to what look at that. And those of you who are interested, just sign up for that. Any questions? If not, let me stop here.